we're told that we have two vectors, A and B. So I'm just going to draw them generally. So let's say that that's my A and that's my B. And we're asked to consider an additional or a new vector, C, that's equal to the magnitude of A times B plus the magnitude of B times A. And what we're asked to show is that C bisects the angle of A and B. So bisecting the angle would mean that that C vector, we don't know about its length, but in terms of the angle, we know that it has to perfectly split the A and B in half. So whatever this angle is, I'll call that theta 1. It has to be the same as this angle theta 2. That's what it will mean to bisect. Well, let's just start by finding one of those angles. So if I wanted to find that angle theta 1, I'm going to use the dot product to help me get there. Since this, I'm looking for the angle between A and C, I would start by saying that the dot product of A and C is going to be equal to the magnitude of A times the magnitude of C times cosine of that theta 1 angle. If I take the dot product of A and C, that's going to look like A dotted with all of this. So I've got magnitude of A, B, plus magnitude of B, A. One of the properties of the dot product is that I can distribute that out. It is, in general, important whenever we're dealing with vectors or matrices. In general, the order that we multiply in matters. It doesn't specifically for a dot product, but because it does in other places, I am going to start being careful about keeping my variables in the same order they started in. Now the magnitude of A, that's not a vector, it's a constant. So one of our other properties in terms of dot product is that if I have a constant, I can kind of just push that out to the front. So distributing this through, I'd have the magnitude of A times A dotted with B plus the magnitude of B times A dotted with A. Now this is a property that if I take a vector and I dot product with itself, what I get back is the magnitude of that vector squared. And we can actually think back to kind of our definition here of the dot product to figure that out. So A dotted with A, since it's the same vector dotted with itself, the angle between, if I have A dotted with A, then the angle between them is 0, which means cosine of 0 is 1. And if they're exactly the same vector, then taking the dot product of the vector is the same as just multiplying the magnitude of the vector by itself. So because they're the same, I can replace that A dotted with A and replace that to be the magnitude of A squared. Now on the right-hand side, again, we were taking the dot product of A dotted with C. So I've still got a magnitude of A, magnitude of C times cosine of theta 1. Since what we're trying to do here is to show that theta 1 is equal to theta 2, I'll go ahead and rearrange this to get the theta 1. So I'm going to have cosine of theta 1. Then I'm going to divide over here by my magnitude of A, magnitude of C. Well, here my magnitudes of A will cancel out, and I'll be left with A dotted with B divided by the magnitude of C. And right here, one of those magnitudes of A will cancel out, and I'll be left with the magnitude of B. Oops, that's not an equals, it's a plus. Magnitude of B times magnitude of A over the magnitude of C. And all of that would be equal to cosine of theta 1. If you repeat this process for theta 2, meaning you take the dot product of C and B, you should end up with exactly the same quantity over here. So that's how you would finish it, to show that those two, that C does bisect the angle between A and B.